welcome to the On.net show. We are trying a different approach today. Bertrand is out on vacation, I believe, and so I'm filling in, and we had a couple snafus with getting the Hangout to start, but we're good now. So today we're going to talk about, actually first we should do announcements like we normally do. So the big news is we shipped .NET Core last week, .NET Core 1.0, so that's pretty exciting. We announced that at the Red Hat Dev Nation conference in San Francisco, and we released bits, which you can get on our website, and you can see our write-up on our blog, and yeah, we were really excited about that, and a lot of people have started using it. Today, we're going to talk about how Bing uses .NET Core. And so we have a guest today, an engineer from the Bing team, and his name is Mukul
Sabharwal. Yes.
Yes, sorry about that. And he's been using, actually, I'll let you introduce yourself.
Yeah, so I work in the Bing team, and we're a .NET shop, obviously, and we're going to talk about basically Bing and .NET Core.
Yeah, that is the story, and I think
that is the story.
We've been working together for a long time.
It's actually been a while. We first we got on this when Bing was going to move to Windows Server 2012 release candidate 4 years ago, and I think that was the first time we started talking about hey, we should talk about it more.
About your use of .NET.
.NET on Channel 9 and stuff. So yeah, this is great.
Yeah, I think at that time, if I recall, that was when we introduced multi-core JITs.
We did, yes.
Yeah.
Yes. We talked about that with Vance and Mounty. We talked about the background GC also. It was both background GC and multi-core JIT, which was both of those things were pretty cool because we got latency improvements and we got startup improvements because of the multi-core JIT.
Definitely. I'm just seeing if this is actually working. Yeah.
Yes.
Okay. Yeah, and what would you say at that particular time frame the performance improvement was?
I mean, we have a blog out. I don't remember exactly, but it was pretty significant. Like this was I mean, there was a lot of latency improvements, and then there was also a lot of operationals because now we can start faster. So there was those things as well. So
meaning you had some mechanisms within your infrastructure to mitigate slower performance, and you were able to basically throw those mitigations out because the native performance was good enough. Is that the way you think about it?
That's sort of one way to put it. One of the cool things that we sort of did at that time was we started, Perfview had also come. I mean, 2012 was actually pretty good. Perfview had also just come out. Vance had put it on his blog at the time, and we basically sort of that was sort of the start from where .NET, Perfview, and Bing sort of became really connected.
Let's move over a tiny bit. I think the lighting will be slightly better. Okay.
Yeah. So yeah, I basically just wanted to geek out, talk about the things that we've been doing for the past 4 years in Bing. So and obviously .NET Core, which is the best thing that's happened to .NET in a while, is something we're sort of marching on towards.
So what would you say? When I think about .NET Core, I think about a couple different value propositions. One of them is obviously cross-platform.
Yep.
Another one is this kind of more flexible deployment model.
Yep.
Obviously, lots of people like the open source thing. Are those the value propositions that kind of apply to the Bing use case, or is it something different?
Yeah, I mean, those are great because we get .NET becomes better because of the community. But I think this is one thing that I think a lot of people wonder. If I'm going to be on Windows, do I .NET Core is cross-platform the only thing that's that's there. Actually, there's a couple of cool things that because of the deployment models. in .NET Core you get. One of the coolest things is the fact that now the runtime is with your app.
Yeah.
And that opens up possibilities like you can use crossgen. And we can talk about that basically to sort of precompile your assemblies, and now you have actual native code. So if you were having startup issues, or if your app really needs to sort of not have that much JIT, then crossgen is a great thing, and that's one of the sort of great value props with Core CLR being part of your app.
Right. That's actually an excellent point. So when you guys cross-gen, do you guys do that in the build lab or on the target machine?
Oh, so we previously, if we had to NGen, it would always had to be, on the specific machine, just because
that was what .NET Framework, because it was required.
It was required, right? Because and the reason I think was your bits could have changed, but different, it's just required. And yeah, now we just you can do it in the build lab. So that's exactly what we do.
Yeah. So I'll just fill people in for just a sec on what it is we're talking about. So .NET, because multiple, .NET has this facility called NGen. Yeah, I was trying to think of the best way to say this.
Yeah.
So it's a native compilation technology, which allows you to compile all your code ahead of time, meaning before the app runs, to native code, such that either all of it or most of it doesn't need to JIT. So just-in-time compilation. So that's super beneficial for startup.
Yeah.
Because at startup, really all you want is that native instructions are hitting the CPU and keeping the CPU busy, executing your app code. The effort of using the CPU to first compile your .NET bytecode into assembly code, which is then executed by the CPU, is not necessarily super helpful. It doesn't deliver the best performance. So a native compilation technology helps with that. So we have a few variants of that. So on .NET Framework, we call it NGen. That has existed for at least 10 years, probably 15 years. And so the way it works, it has this characteristic where you have to do that on the target machine, on the machine that the app is on. And you actually have to install the app first.
That's true. That's true.
Yeah, the app has to be there already. And with .NET Core, since it's self-contained, basically it's similar in some sense, which is the app and the runtime have to be together at the point of compilation. But since .NET Core can be self-contained, as long as the app and the runtime always are distributed together, then it all works. Everything's self-consistent, and that native compiled code always matches the runtime, and everybody's happy.
Yeah.
And this is a little bit distinct from our .NET Native.
Oh, we're back on.
I think we're back on the air now. Sorry about that, folks. Yeah, so we had just finished discussing how cross-gen and NGen works. I think the part that got cut out is we were talking about how cross-gen is oh, that's right. Now I remember.
We're talking about the pull request that we should make for the documentation.
Yes, exactly. So we should talk document cross-gen a bit more. We just haven't quite gotten to that. So that was the only part that got missed.
Yeah. Okay, and so then I was gonna talk about the fact that sort of Bing uses .NET 4.6.1 with Vue.jit, and which is we have faster compile times because of Vue.jit when we move to Vue.jit, and the march to sort of to talk about .NET Core, the march to get to .NET Core, which is sort of been an interesting exercises we've been going through and working with the .NET team to make it easier for the next set of people who want to migrate. So I definitely wanted to chat about the thing that the Mscorelib facade that we ended up making.
Oh,
which was really actually, I remember the pull request. It's called 4874. The pull request was 4874 on Core CLR. the reason why, if you were a .NET developer and you wanted to port to .NET Core, prior to that pull request, I mean, it was we had to basically, you had to still have to use the same compilation tools, but there was a lot of stuff that was potentially missing. But with that pull request, we enabled Mscorelib as a facade, and that basically has given the .NET team and anybody actually the capability to, we can start adding things, and that would be like a great migration strategy. So the binary compatibility for existing apps becomes really sort of compelling, because a lot of stuff will work as we release. I mean, we've just released the facade right now, but in our next .NET Core release, there'll be more APIs, more binary compatibility, which is fantastic.
Yeah, I mean, definitely one of the goals is, or actually, we should back up. Tell me why, maybe you said this, I was fiddling a little bit, trying to make sure everything's working. Tell me why an Mscorelib facade was so important to you. Like, you could say like, oh, this particular Mscorelib collection, or this particular collection is not in .NET Core, so I'll just make a system.collections foo package, and that'll then enable that functionality, and I'll be good. As opposed to basically creating this Mscorelib assembly with all of this functionality in it. Like, why did you go that route?
Well, the key thing to sort of think is, people have .NET assemblies which they've built over the years.
Yeah.
And the thing that every assembly has in it is that it's sort of compiled against Mscorelib. And so you can imagine that all their, so we're going to start off getting a little technical, but I'll sort of explain. You have an assembly, and that assembly is sort of linked against Mscorelib, and Mscorelib has a system collections, something is defined there. So your .NET assembly is referring to that, and in .NET Core, prior to this pull request, which did go out in .NET Core 1.0, you'd have to, your assembly wasn't compatible. It may be compatible because ultimately Mscorelib was still there, but now what we've done is Mscorelib is just a facade. So I'll explain what that means. Basically, this assembly, the mscorelib.dl, it's like 30 kilobytes now in .NET Core. It basically has type forwarding information, and the type forwarding information is going to the renamed assembly, which we call system.private.corelib, right? And it's sort of redirected to that. But the good thing about having the facade is that now my .NET assembly that was mostly cross-platform, I wasn't pinbooking into Windows functionality, and it was just using like a dictionary and a few things. Now I suddenly take that assembly, put that in .NET Core, and it just works because the Mscorelib facade is sort of type forwarding to things that are in .NET Core. So that was key functionality.
Yeah. So kind of what I'm hearing is there's probably a significant percentage of .NET assemblies that have been written over time, particularly actually in the earlier years, just because there was less functionality available, and they didn't take advantage of the UI stack. They didn't p-invoke into native code. It's basically just simple, and I'm not using simple in any bad sort of sense. Yeah. It's just simple C# code.
Yep.
Or VB, doesn't matter the language, but it's simple .NET code that uses fairly basic .NET concepts and types. Just because its assembly references don't necessarily match, or its NuGet target framework doesn't necessarily match, doesn't mean we should stop it from running.
Exactly.
People should have the option to kind of opt in to kind of a compatibility layer to at least try to see if it works. And I know when I talked to Miguel, actually, he's of the opinion, which I agree with, which is not only like there's the one case of assemblies that perfectly play within the lines and will work. There's other cases that actually have some functionality that is outside the lines and some that's inside.
Yeah.
As long as you call within the right code paths, you're fine. So
yeah, I'm actually
you should be happy.
I'm also in
that camp.
I also in that camp, and is that if the assembly is isn't going to call into some method, and that's I mean, obviously, it's from Microsoft. We can't go and tell everyone, hey, this will just work, and because then they'll be upset because some code path, some exceptional code path got taken that did end up p-invoking. So there's stuff like that.
But that's opt-in.
But that's opt-in, right?
Yeah.
And this sort of capability, this pull request, sort of this feature, which was I was like really sort of pushing for, got into .NET Core, and basically gives us the capability, us and the open source community, to keep adding things back in and sort of pay for play manner. So one of the things that I remember there was people were talking about is, well, are you bringing all the APIs back and it's going to be bad for performance? Not really. It's just an opt-in functionality that you can use.
Yeah. Well, we're glad to help you guys on that front. So maybe we should talk a little bit about. So Bing is obviously a cloud workload.
Yeah.
So it feels like it's quite kind of topical and modern in the kind of app that it is.
Yes.
Can you talk a little bit about, I guess maybe where you've had success using .NET for that kind of workload? Like obviously Bing.com gets a bunch of requests every second of the day.
Oh yeah. So I mean, Bing.com. I mean, it's like other Microsoft cloud services. I mean, Bing is it's a really big. It's a really big service, and you can imagine we get like thousands. I mean,
bazillion.
I mean, couldn't even come up with a number. Actually, it's probably a very large number of millions. So obviously for us, as a cloud service, stability matters a lot. You don't want to give, you don't want to, Bing.com shouldn't be down for some reason, or so there's a lot of stability that comes with running managed code. There's a whole class of bugs that just don't happen, and so running .NET and then ASP.NET has been sort of really successful. With obviously with .NET ASP.NET Core, there's going to be even more sort of room for improvement with respect to perf, but basically perf definitely matters for Bing. And one of the things is that it's not just .NET; it's the .NET ecosystem. It's the tooling around .NET. It's the profiling tools. It's the profiling APIs. All that stuff that's there in .NET, and some of it which is in .NET Core, is basically one of the sort of strong pillars that Bing relies on pretty much on a daily basis to basically people to diagnose the problems or yeah.
I see. So you're saying you guys go a little bit beyond, just pure Visual Studio and IntelliSense. There's some, we'll say, high-end diagnostic APIs for probably performance and reliability, and to be successful. Just because tomorrow it might be the Super Bowl and you get a big spike.
Yep.
And so, your logs come in, things weren't as good as you wanted, so now you need to prepare for next year's Super Bowl kind of thing.
Exactly. And so
it's funny thing is I'm not even a football fan. But anyway, no, I like other sports.
You like other sports. Okay.
Yeah.
Well, definitely one of the things that we use in .NET is the profiling APIs, and also Purview, which is if people haven't used Purview on .NET, it is an amazing tool. Everyone should use it. So what in Bing you can imagine we're a cloud service, so people aren't opening Purview on the machine and stuff like that, right? So we have what we've done is called Purview as a service, which is basically it's basically running Purview in a mode that is sort of separates the data side of things, which is talking to on Windows ETW with the UI layer, because we don't have to use the UI layer on Bing.
Right.
So we have we have an ASP.NET app that can get that profile data and show it to you as a visualization, as opposed to looking at itself in Purview. So the thing is that I did talk to Vance, and we're at least his plan is that the data APIs that gets split inside Purview, so it will be there for cross-platform purposes, because Purview.
Nice.
Because I mean, we've blogged about it that Purview can actually open up Linux-based performance data. So you can imagine this applies to a lot of scenarios and a lot of other cloud services can start, using these technologies that we'll start enabling.
Right. So another way of saying that is if you're using .NET today on Windows Server in kind of the sort of scenario you're doing, which is a high performance cloud service, and you rely on these extra tools, if you so happen to move to other operating systems, you'll actually be able to use the same tools, have the same experience.
Yeah, I mean, I just want to caveat that yes, you have to use Purview, for example, which will but yes, the idea is that we want to bring up everything that we can for .NET to be there for .NET Core, and why not, right? It's a great platform to be able to take your code, run it on Windows, and if you want to run it on Linux or Mac OS X, you should be able to.
Makes sense. So I was just going to bring up one more topic, and then I think we'll be getting pretty close to time, which is, I know with a bunch of folks we talk to, and there's a bunch of emphasis on this in the industry, of microservices and containers. I guess two questions on that. Is that, if you can talk about it, is that something that Bing thinks is important for your kind of cloud service? And how do you see .NET fitting into that kind of model?
So yeah, absolutely. I mean, microservices is in some sense, the industry trend and term is there, but you can imagine cloud services like Bing have a disparate set of services. So the industry trend of microservices is absolutely one of, it is. I see working with Bing every day. It makes total sense for so many applications. So yes, it's definitely Windows Server 2016 has containers for Windows, so it's going to be pretty awesome. And .NET Core, I mean, the fact that you're going to have that app and it runs the runtime with you is going to be incredibly important, because more microservices will want to take, they'll want to version independently. And the key concept there is, if you want to version independently, well, you got to make sure that the runtime is also versioned independently. And so Core CLR and .NET Core being part of your app, that deployment model is going to be, I think it's going to be, the shared runtime is what we've sort of put out right now, but that's going to be sort of the next key thing that will enable large set of apps.
Yeah, I mean, I definitely think that, so there's two different deployment models for .NET Core. There's the shared framework kind and then the standalone kind. I actually think they're both interesting for the container, because there's really two models. It's like, one is my container app is completely, unique and standalone, and I just want only in terms of it. And the other one is actually, I want to make a broad decision about my base platform across at least this release of my app. And the benefit you get from that is, with containers, you kind of have this inheritance relationship. And then that base container that has the shared framework in it is actually shared across all the apps. So that can actually help from a density perspective. True. So I think actually both of them are interesting. But the fact that in both cases, .NET Core is distinct from the operating system, so you actually get both of those choices. So I think that's what makes it fairly container friendly.
Yeah, it's .NET Core. I mean, I get you talking about .NET Core, but it is literally the best thing that's happened to .NET in such a long time.
Yeah, and I think it's quite well aligned with industry trends. Another thing which you kind of touched on is, for .NET Core 1.0, we have both shared and standalone. I would say we put 90+% of our effort behind the shared model. We knew that we wouldn't be able to do a good job with both, so we put our effort behind the shared one. We thought, I mean, for one, that's the experience you use in development.
Right. Yeah.
And then we thought more people would be either happy or happy enough with the shared one for 1.0. And then we've actually started talking about the experience for the standalone case again. So I'm not too sure when the awesome story for that is going to come out. We don't have a timeline yet, but super important.
Yeah, the shared runtime. I mean, it makes total sense. That's what all our .NET developers were used to. They were used to .NET being a either in Windows just runnable and this .NET command line. So
a unit.
It makes total sense that shared runtimes comes first.
Yeah.
It's great.
Yeah. So so I think we're going to continue to work together.
Yep.
I think it'll be interesting to see. We should probably do this again in 6 months or something like that. And talk about when Bing actually starts putting out production workloads on .NET Core.
Yeah, exactly. That would be great.
Yeah, and then we can kind of talk about what that experience was like.
Yeah, happy to be there.
Yeah, I think since we had some troubles with the call today, we don't actually have any questions this time. Yeah, well, thank you for coming on the show. It's awesome. And I'm not quite too sure who's on the show next week, but we'll definitely post that on Twitter and on the blog. And thanks for watching.